Thank you for joining us for our educational session under REPS, Packaging Materials, Their History, Their Efficacy, and Creating Packaging Material Inspection Protocols. In this session, Shawn Engberg will provide the history and evolution of sterile packaging materials, data regarding surgical site infections and compromised wrap materials, and sterile processing's important role in successful sterilization of sterile packaging materials. By the end of this session, we will also help provide protocols for creating departmental checklists based on standards and guidelines to help promote sterile packaging material integrity to ensure patient and staff safety. Shawn Engberg has 20 years of service in the operating room and sterile processing departments. He has served as an operating room facilitator, neurology and orthopedic surgery coordinator, and as a sterile processing manager. Shawn is a member of ISHM and has been an affiliate of Advantage Support Services and serves as a volunteer for AAMI's Standards Committee for Sterile Processing.
Good morning, sterile processing. I hope everybody is well and healthy with all the chaos going on today. I know it's been a little crazy and you guys have been on the front lines, and we really appreciate all that you're doing for patient safety and infection control. So today I just wanted to talk a little bit about CSR wrap and the history of it, how it's evolved over the years and where we are today, just to kind of help out with some history and to kind of get where we are today and how it's working and the barriers and everything that we can do to help with infection control. About 80 years ago is when the first wrap came out for wrapping sterilization pans. It was a 140 thread count muslin cloth. It did have some advantages. One of the advantages was it was soft, it was reusable, inexpensive, and drapable, which is really nice. It was really easy for you to drape a pan, wrap a pan, and do whatever necessary to make sure that that pan was covered completely for sterilization. It was also really soft and easy to use, so it was really good when you were using it. It was when they were removing it from the shelves, putting it on the case carts and all that. And it was inexpensive. It was an inexpensive cloth, and it didn't cost much to be able to wrap a pan. So those are some of the advantages of it when they first started 80 years ago. The disadvantages to this was that the cloth was woven, and it did not provide a complete protection against microorganisms and contamination. So what they had to do to try to help with that and to try to make it a little bit better for barrier and to keep those contaminants out, they actually had to use two of them. So they took two of the woven 130, 140 count wrap, and they actually would wrap twice. So what ended up happening is it was not as efficient as it used to be. It was starting to be more expensive, and it took you guys more time because you had to wrap the pans twice. So that was very difficult to do over time and made it kind of inefficient and not worth the time. So then in the 1960s, they came out with a new material. It was a non-woven material. It was pretty effective. It was right path to go down for protection for contamination and treatment for ways of being able to give a better barrier so that we could go through and make sure that the contaminants were not being introduced into the pan. It was liquid resistant, which was also nice, which on the 140 count it was not. So, liquids could soak through there, which made it really difficult to make sure that it came out dry. As you sterilize them, you got to give them that 45 minutes of dry cycle time. So this made it really liquid resistant, made it nice because that sped up that time to be able to let that dry. But it still was not efficient. It was a one-layer wrap, which at the time we thought was really well built because it had that protection and that a little bit better protection. So then what happened over time is you guys had to do the same thing as you had to do with the 140 count wrap and the soft wrap. You had to start using two because it was easy to puncture a hole through. It wasn't as protected as we thought it was going to be. So over time we had to go out and say, okay, now we have to wrap this twice to make this happen. And so that made it really difficult, started to make it to where it wasn't efficient anymore. And the cost, of course, to healthcare and all that went up because you're adding more supplies to an item that you shouldn't have had to. And then, as we are and where we are currently today, we came out with a polyolefin wrap, which is great because it possessed strength, barrier, and repellent properties. And then we went from there and we went to the current area of where we are today, and that is a 3-layer bonded material, an SMS layer. So basically what it was a spun bond and melted blown wrap. The fabric was consistent of basically a thermal bonded layers, and what that did was it gave you just ultimate strength. It gave you the strength of hopefully of it not tearing, hopefully being able to protect the pan from getting holes and anything else that might be able to go through. So it was very, very excellent material for protection for microorganisms and contamination. But what happened was is you got those 3 layers together, and they were still having problems with getting holes going through the pan. When you get into orthopedic pans, they never are at the weight that they should be, 25 pounds. So when you started wrapping those pans and you get a good orthopedic pan with all the trials and the inserts and all that, what happens is that pan was about 30 pounds, and it did cut down on the pan weight using the wrap. But then what happened is that wrap started to get holes. So then they came back and said, okay, we're going to have to go through and find a way to help prevent these holes, or how we see those holes. So manufacturers went out there and they started making not only a 3-layer bonded material, but they took 2 3-layer bonded material and put them together, and they heat sealed them together on the edges. First they started out with blue, and so it was blue on blue. Then what happened was that blue on blue didn't work because they still were not able to see the holes. What they did is they started to come out with different colors. So they did a blue on white, they did a blue on pink, a blue on green, and a blue on purple. And what happened was is they were hoping that those areas would in turn show them that if there's a hole, you could see the white coming through the blue. What happened was is that did work. It worked fairly well for 2 centimeters to 5 centimeters. But then what happened is when you got under 2 centimeters, it was very difficult to see with the naked eye. What they tried to do is they did come up with a great system on how to detect a hole and to try to make it so that we know that it's a contaminated tray, but it still is not quite 100%. So then when you take them up to the OR and you look at them and you try to look at them with your naked eye through just a regular OR light, it's very difficult to determine a 1 centimeter hole. So you don't know if that pan is contaminated or if that pan is 100% sterile and able to do what it needs to do. So what they did next is they came out and said, okay, most of the holes are coming from the corners. Corners have a little bit sharper edge. So let's go ahead and let's make strips, and let's do bubble wrap, and let's do other things that we can wrap around those corner protectors and wrap around those edges to try to prevent holes. It makes sense. Okay, I know most people in sterile processing do not like corner protectors. I hated them when I was wrapping because first of all, they were so difficult to make sure they stayed in position when you needed them to stay in position. And third, you're doing 2 layers of 3-layer bonded material, and it's still not doing the trick. So then you have to wrap, and then it's just basically doing the same thing. You have to do a double wrap on the corners. So it's become very inefficient. It's starting to cost more money. It's starting to be kind of a sore spot for sterile processing because they just don't know how to resolve that issue. And so the first defense of all this is sterile processing. I mean, you guys are the front lines of infection control. You're the front lines of making sure sterile stuff is sterile for the ORs and patient safety. Boy, you guys are the best when it comes to patient safety. So what that means is you guys, I know a lot of times we don't look at the wrap. We just throw it on the back table or we throw it on our workstation and we just start wrapping pans. We put towels down now, which is even more expensive. An average towel is $1. So a lot of times you put 4 towels in there because you wrap them twice, and then it just gets to be it starts to be a burden and it starts to be a pain because you're trying to find out ways to stop these holes from happening. You know, what I was trying to do was kind of give you guys a history of that and how that all works and how we can try to prevent that. And, sterile processing, we need to start looking more at the wrap before we use it to make sure that there is no holes, to make sure that we can see a 1 centimeter hole, to make sure that we are getting those before we wrap them. Because a lot of times that wrap probably has a manufacturer defect before we even use it, probably 90% of the time. And then on top of that, if we catch it first, then we can get that out of the system and get one we know is 100% barrier proof and can be sterile, so that when it goes upstairs, the chances of it being ready and sterile is at a higher number. Where we're at today is perfect. Where we're going today is perfect. We have some great barriers and some great ideas. We just need to come up with more efficient ways to not have to add more pieces, not have to add towels, not have to do this, not to do that, to try to help with this situation with CSR wrap. Because the ultimate goal is you don't want to see light coming through the other side. We want to make sure that those things are barrier proof, contamination proof, microorganism proof. We want to make sure that pan goes up and it's sterile, it's sterile. We want to make sure that there's nothing that can get through that wrap or that barrier point to cause any problems and to increase the infection control that we're trying to understand in the OR. Now let's talk about surgical site infection. That is a big topic today, and all the areas of things that are coming out, coronavirus, and new infections like nephritis fasciitis and things like that. Infection control is a big issue this year, and we really need to look at those areas when it comes to surgical site infections. we're all want to team up and make sure that we do what's best for the patients and what's the best for infection control. And sterile processing, you're the front lines of that. You guys are the first step to infection control and surgical site infections. It's amazing how much knowledge and everything that you guys need to know to be able to conquer that area. It's a big area to conquer. Now, with everything that's increasing and the number of cases, we used to be able to do 35 to 100 cases a day in some small facilities. We have some facilities that do up to 300 cases a day if you have 16 to 20 ORs. The surgical site infection has increased over the past few years. 5-6 years ago it was 13%, and then a couple years ago it was 17%, and now they're estimated to be about 20% of surgical site infections. And the highest area of surgical site infection that right now that they're finding out is a lot to do with orthopedics. Orthopedics is about 33% of that. But you got to realize the cavity is open for a longer period of time. You're doing a total knee, total hip, total shoulder. It's an area that you can definitely see why there'd be more infections if you've ever worked into an orthopedic room. But it's getting to the point where it's getting high, and everybody needs to look at surgical site infections. The annual estimated range in the U.S. is 160 to 300 patients a year. That's just a lot. That's a lot. It adds up with the cost. The annual cost range is between $3.5 billion and $10 billion. So you just have a lot of area that just needs to be focused on when it comes to infection control. What's the one thing that we do when it comes to orthopedic pans? Orthopedic pans, a lot of their pans are so large and so heavy, you can't put them in an Aesculap coffin. Because what happens is once you put that pan in there, the increase of weight goes from 25, which is supposed to be the maximum weight of a pan, goes to 35, 45, and higher. So they get very difficult to be able to handle. Nurses have a hard time pulling them off the shelf, putting them on the case carts, getting them ready for cases. It causes more problems and can cause more injuries to the staff as well. What's the next solution to that problem? It comes to the 3-layer CSR wrap, the bonded, melted, blown wrap. And so what we're trying to do is to make them lighter and keep them where they are. We go and we take the wrap and rewrap the big pans and orthopedics. And then what happens is you get those wrapped, you put them up, and then you have that extra weight on those pans. And then you hope that those pans get sterile, and you're sliding them onto the sterilization rack. You put them in the autoclave, you pull them out, you let them set for 45 minutes, you take them over to the storage rack, and you hope within those 4 steps right there that you don't get any holes in the weight of it. The weight of an orthopedic pan, when you have 10 pans per case, is a lot. Then it comes down to determining where we're at. Then you take that off the storage shelf, you put it on the case cart, you haul it up to the OR room, and you hope that out of the 10 pans that you have, which majority of them, 90% of the pans are CSR wrapped, you hope that they don't have any holes. Then you get into the OR room, and then you hope that the circulator or the nurse or the scrub, whoever's inspecting those, can see those holes. So you lift them up to light, and you just hope that you catch those holes that are 2 centimeters to 5 centimeters. Anything below that, you just hope you catch it, and it's really hard to see with the naked eye. That's where infection control and where we're at with everything on CSR wrap. The other thing that you're trying to do when you're trying to control holes and trying to control infection control of those pans is, what do you do with the heavy pans? You take them and you put a towel or you put a corner protector in those pans. So what do? You take a laundered towel and you put a laundered towel underneath the pans, usually 2, sometimes 4 on each corner, just to make sure those pans don't get holes. Then you rewrap it. Well, not only do you add another barrier, another area that has already broke the barrier of CSR wrap and has gone now into the pan to where you can introduce more bacteria, more microorganisms that are on that laundered towel. You don't know that, but that could be possible. Then you wrap the pan. What we really need to do is find ways that we can determine and detect defects, holes, anything lower than 1 centimeter. We need to be able to show that we can detect that before that pan even gets wrapped. We all do the same thing. We just lay the towel on our workstation or the CSR wrap on our workstation. We never really look unless that white or that pink or that blue stands out, then we know there's a hole. But if we don't actually look for it, we don't do anything. So what do? We put the towels down, we put the heavy pans on there, we wrap it, and we go. And then you take it upstairs, and then you hope that there is no broken barrier or hole in that pan. Because then what happens is then you have to take that pan down. You have to bring it down, and you have to re-sterilize that. With the increase of surgical site infections going up every year, the cost of it going up every year, The average stay of a patient being in the OR for 7.5 to 10 days or more is just unbelievable. And then you got 2% that you hope that you catch. It's really hard to talk about surgical site infections because there are just so many determinants out there that can cause a surgical site infection. But in sterile processing, if we can go and we can look at the CSR wrap and we can detect the defects and we can look at it and say, is that a hole or is that the weave or is that a defect? And we can detect anything under 2 centimeters, then we're doing really well. That shows that we checked that and we had that barrier and we knew that barrier was covered before we wrapped that pan. Then we move from there and hope that we can go from there. We don't want to delay a case. Average case is $125 to $150 a minute. So we don't want to delay a case. That upsets a surgeon. That keeps the patient under anesthesia longer. And that makes us have to do more work because then we're going to have to bring that down, re-sterilize it, and reprocess that pan, which then costs more money when an average pan to sterilize runs $150 from the time that you guys wash it to the time that you guys inspect it to the time that you guys do the layers, put the indicators in, wrap it with CSR wrap, determine whether or not you're going to use corner protectors, determine not whether you're going to use whatever you need to use, and then autoclave it and then set it off for 45 minutes. You're looking at about $150 a pan. So that gets costly when you have 10 average pans on orthopedic cases, and if it's a total revision of a total joint, you could have 20 pans on the back table with CSR wrap, and those pans are so big, so you have to use CSR wrap. You have to because they won't fit in the Asculap sterilization pans. They're just too big. You guys being on the front lines and doing that inspection of that wrap is so important, and of course we appreciate all that you guys do. So now that we talked about surgical site infections and how they're increasing over the past few years, and really what the cost is coming down on hospitals for those surgical site infections, it's time to talk about how accurate we are at looking for holes in sterile wrapping. There was a study done back in February 2018 by the Clinical Orthopedic and Research Center. Great study. And they put a table together. And what they did is they took 240 pans and they wrapped them in sterile wrap. And they put different size holes in them. And so there's a couple things really kind of interesting about this study because what they did is the smaller the hole, which we all know, the smaller the hole, the harder it was to determine if that was a hole or not. What they did is they started out with a 0.86 millimeter hole. We were only able to detect that 5% of the time. And then as it gets higher, 1.0, it was 3%. Then we get to 1.25, it was 18%. And then for some reason it drops again and goes 1.6, it gets to 3%. Then 2, it gets to 7%. And then there's a dramatic increase of us detecting defects once we get to 2.5, and it jumps to 76%. Then it goes to 95%, 93%, and 83%. So really what this table shows us is, one, we're not accurate, and we're not doing a good job at inspecting sterile wrapping to determine whether there's holes. So what the manufacturer has done to try to help us with that is they went to different colors. So they did blue and white, they've done blue and pink, they've done blue and purple, and they have blue and green. I think those are the 4 that I've seen. They're hoping that those different colors will help us to detect if there's a hole or a defect in that wrap. You hope that that white shines through, or that purple shines through, or that blue shines through, or whatever color it is. But what we're finding out is even with that, because back in 2018 we were using the 2 different colors, 3-layer bonded material. Really, it's showing us that this accuracy of us determining whether holes are in there or not is not good. So, I mean, we should be around 95% accuracy when it comes to finding holes. And that's just not happening. What they found out was that from their study, the operating room personnel examining and identifying the integrity of the wrap and if there was a hole was overall about 56.1%, which is not good. And then anything from 2 centimeters to 5 centimeters was around 67.2%. But that still is not good. Whenever we're inspecting a wrap and whenever we're looking for holes, we should be around a 90% accuracy at all the times. So what this really tells you on this study is that we're just not accurate. At this time, they knew we were doing the study. They knew that their stuff was going on. And so they probably had a lot more accuracy than what is actually truly there. And we know that anything below 2 centimeters and lower, we just aren't detecting it at all. I mean, 5% is not a good detection of whether or not that's a hole. So the accuracy comes down to us as a scrub tech, a circulator, and sterile processing. And so that's where the next step has to occur. Training. Training is important. Sterile processing is the first line of infection control in an operating room. And so that's the first line of defense. What we need to do is we need to come up with a solution or a way to where sterile processing can look at that wrap and make sure that there's no defects, make sure that we can detect anything 1.0, and whether or not we can see that that integrity of that wrap is overall good and accurate, so that we know that there's no cross-contamination or any chance of bioburden or anything getting through that wrap. And that's going to be hard to do just by looking at it through a light, sticking it up to a light and looking at it from your eye to that. You got to hope you have good eyesight. You got to hope that going through a 48 by 48 wrap that you check every piece of it. Sterile processing, what we can do there on that side is when you're wrapping the pan, being able to detect any defects or holes right from the beginning, right at the start of when we're getting ready to wrap that pan. I know when we were on the back table, when we were in sterile processing and working at our workstation, I would take a 48 by 48 wrap and I would just lay it on my workstation, put the towels in there, wrap the pan, do everything that was necessary, put the indicators in there, tape it, and get it ready to go. And if I could not see the white, the pink, the green, or the purple coming through that after I wrapped the pan, as far as I was concerned, that pan was fine. The integrity of that wrap was good. But that's not good enough anymore. With the increase of infections and surgical site infections, it's just not good anymore. So we need to get the accuracy from 56.1% on no matter what size the hole is up to 90%. We're using wrap on heavier pans, orthopedic pans. 30% to 33% of every surgical site infection is resulting from orthopedic cases. And what do? We use sterile wrapping. And the reason we use sterile wrapping is because you can't put those in an Asculap pan. They're just too big. They're too wide. They're too tall. And for them to be able to get all their trials and all of the inserts and everything that they need to do, a total joint, a knee, a hip, a shoulder, what do you have to do? You're going to have to wrap it with sterile wrapping. Before we put that wrap on there, we need to determine whether or not there's a hole. We need to make sure that there's no defects. We need to make sure that that wrap and the accuracy and the integrity of that wrap is 100% before that goes up to the OR room. And then we have to make sure that the OR staff and the surgical circulator and the surgical scrub all know how to detect the holes in that area, especially when it gets up to the OR. Right now, there's 27 million surgical procedures every year in the United States, and 5% of those are surgical site infections. 5% is a lot when it should be around 1% of surgical site infections. Now, whether or not it comes down to surgical wrap or whether or not we're just not doing the back table right or we're not prepping the patient right, that doesn't really matter. What we need to do is we need to make sure that the wrap and the pans come up with the integrity and the barriers not being affected so that we can make sure that that pan's sterile. So how do we do that? We need to inspect the CSR wrap and the sterilized wrapping before we wrap the pan. We need to make sure there's no imperfections. We need to make sure that there's no holes. We need to make sure that the sterile technique that we are doing every day is to go through there, check, and make sure that those pans and that there is no compromise on the barrier. And if we can get that area and sterile processing down to 93%, knowing that that's a good wrap and that's good to go, then we're doing pretty well. That's going to do really well to make sure that when we take that upstairs, it's going to give us what we need to make sure that we can 100% say that that is sterilely wrapped and there's no chemicals or organisms going through that wrap. Now, there's always other determinants. We need to make sure that everybody in the OR is checking it as well and inspecting the wrap. It's really essential that everybody is on the same page and that we're all working together for infection prevention. But one way to doing that is just being more accurate. We're not accurate at determining whether or not there's a hole in sterile wrap. And so sterile processing is awesome because we can start that in that area first. That's the first area we can start with. That's the first area we can go. That's the first area that we can say, hey, this wrap is 100% ready to go, ready to do its job, and to make sure that all the barriers are there to keep out contamination and to prevent any chance of infection getting into that pan. That's the determining of all of anything that sterile processing does. And that's why sterile processing is so important, because being the front lines and being the first to determine and to detect infections is so important. And it's so vital to a successful surgery and for a successful outcome for the patient. How important you guys are and how things work is amazing. The study was great. It just showed that we're just not accurate enough in determining the different size holes and the integrity of the wrap. And so that's where we really need to look at to try to help to decrease surgical site infections. What we've learned from the study that was done by the Clinical Orthopedic and Research Center is that determining defects between 2 centimeters and 5 centimeters, we're accurate about 56.1% of the time. And anything below 2 centimeters, we don't have a determination or an accurate read on defects or holes in the sterile wrap. What we do know is that we do not have a current method for assessing sterility, and it is not accurate. So how do we fix that? And what do we do when handling pans so that we don't get holes and to prevent holes from going from sterile processing up to the OR? So the first thing that we can do in the first line of defense is sterile processing. In sterile processing, being the ones that wrap the pans, what we can do is have a system put together at finding imperfections, defects, and holes in sterile wrap. What we need to do is come up with a system to where we can be more adequate at finding holes below 2 centimeters and being a little bit more efficient and more accurate with holes between 2 centimeters and 6 centimeters. Because what we really want is we want to be between 80 and 90% of the time we want to know that we have detected or found holes or defects. Because what we don't want is we don't want to be sending up a pan that has a hole and that can be compromised. Anything below 2 centimeters is like a pinhole, and just that size of a hole can transmit contamination. If you have holes in a sterilized surgical wrap and they're not identified, the patients can be exposed to dangerous pathogens. The other thing is you get to the point, if it does have a hole and it gets ready to go onto the back table, it has to be taken down, and then what happens is it compromises the procedure. It compromises the time that patients under anesthesia, and it also compromises the time that you're going to need to sterilize the pan, because that pan's going to have to go down. It's going to have to be re-sterilized because it now has broken the barrier and is no longer sterile. What we need to do is we have to come up with a more effective way and a better way of determining and finding defects and holes in wrap. The other thing we need to do more training. We need to train, and we need to train to the point where we can show more detailed detection of compromised wrap. So not only do we want to be able to do that with sterile processing, but we also want to be able to do that once it gets up into the OR. And we want to be able to ensure that the sterile processing team and the OR team knows how to inspect and to find those defects and flaws in the wrap. We need to come up with better systems. We need to come up with a better system to be able to do that. One thing we need to do also as well is we need to handle the pans better. So once the pan is sterile, and it goes from sterile processing and it gets sterilized, goes from the autoclave rack and then goes to the storage unit and the storage shelf, we need to be able to take that off of the shelf, something to protect the bottom of it so that once it goes on the case cart, it does not have a chance of rubbing it up against anything sharp. Something that we can do to prevent holes from happening. And then once it goes up to the OR, we got to be able to do the same. As it's coming off the case cart, we got to be able to make sure that that does not get damaged by any ways that could compromise and cause cross-contamination. That is one of the biggest questions that we have when it comes to sterile wrap. Yes, it's an efficient way of doing it. Yes, it helps with the weight of the pan, and it helps with larger pans like Orthopedics, which is one of the number one areas of SSI. But then we have to make sure that it's efficient and that it works so that the cross-contamination is not happening. And the only way for us to do that right now is to be doing more detailed training for detecting compromised wrap. Training the sterile processing team to look at it from the beginning, and then training the OR team when it gets to the end, and to make sure that that pan is sterile and the sterility of it is accurate, and that we know that there's no contamination and no possible chance of infection being transmitted into that instrument tray once it's on the back table. One thing that's for sure, and we all know, is it's all about patient safety, and we want to make sure that we do everything possible to make sure that that case goes well so that the patient is safe and there's no chance of infection. Is it a cost savings and it is efficient to be using CSR wrapping for pans? And so that's a great question to ask. We know that if we cannot come up with an accurate way to identify cross-contamination, and if we cannot detect and have a better way of detecting holes and defects in the wrap, then we know that it's not going to be a cost savings and it's not going to be efficient. If we know that orthopedics, it's the number one area of infection in SSI. We also know that orthopedic pans have a lot of equipment, have a lot of instruments, have a lot of trials. So a lot of times they don't fit in a metal sterilization pan. So then our next solution to that is using sterilization wrapping. If we're not being able to effectively get that pan to the OR from sterile processing to the OR for surgery without having a hole or not being able to determine or detect a hole, then that just throws everything out the window. The cost savings and efficiency no longer exists, Because if we get that pan and we get it wrapped and we get everything going, we get it up to the room, and then we use our 56.1% accuracy at the time to determine, and we actually do find a hole between 2 and 5 centimeters, then guess what? We're having to start all over. What happens is it delays the case, and sometimes the case can be canceled because of that pan, because there's something special in that pan that we needed. The impact of re-sterilizing a pan from the time that it starts to the time that it gets back on the shelf is $150. So that is a really big expense when you think about that. When you have a sterilized pan and you have 10 other pans that possibly can be contaminated as well because they're wrapped in sterilization wrap, that takes that cost savings and that efficiency right out the window. And then if they decide that they're going to wait for that pan, then you have the patient under anesthesia for a longer period of time. And what happens is that the average cost of an OR is $125 to $150 a minute. So every time that you're waiting for that pan to be sterilized, that $125 and $150 a minute is adding up. It takes 17 to 20 minutes to re-sterilize a pan in an autoclave. What you have to do is you don't have time to take it downstairs and run it through the whole process. You have to bring it upstairs, and then you flash it. And when you flash it, and most of the time, orthopedic pans have 4 different levels. So you're only able to flash 2 at a time. So you take that 17 minutes for 2 layers, and then that adds up to 4 layers, and you get where I'm coming from. All of those costs start to occur and start to add up. And then that just totally gets rid of the cost efficiency and the cost saving. And then, of course, it puts the patient at a higher risk and a higher chance of an infection. And then, of course, you have decreased physician satisfaction, which is important, but it's not as important as it is to be able to make sure that the patient is safe and gets out of there safe. The best way for us to be able to make this happen and to be able to make sure that there is a cost savings and it is efficient is we have to come up with ways to determine and to detect holes and be able to detect defects or anything that might compromise that barrier and might compromise or have any chance of cross-contamination. So we have to go back to the beginning, back to the basics. We have to go back to doing more detailed training for detecting compromised wrap. We got to go back to sterile processing, and we have to do the same thing. We've got to be able to train. We've got to be able to detect and be able to see those areas that are compromised. And right now, with where we're at, and from the study that we learned, we're not able to do that. Right now, it doesn't look like it's a cost savings and it's efficient, because if you're having to double wrap it and if you're having to re-sterilize it and you're having to delay the OR time and you're having to delay everything that goes into this to make this process run, then no, it's not a cost savings and it's not efficient. How do we get around that, and what is it that we need to do? We need to come up with a system and a way to be able to detect and determine and to make sure that there is no way that there can be any cross-contamination in that wrap. And we need to make sure that that barrier is not compromised from the time that it starts in sterile processing, from the time it goes to the storage shelf, from the time that it gets pulled onto the case, and from the time that it goes up to OR and it gets opened and put on the back table. And we have to do that in multiple stages. We have to do that with sterile processing right from the beginning. We have to do that from when sterile processing takes it from the actual preparation and the prep and pack table to when it gets put on an autoclave rack to be autoclaved, from the time that it comes out of autoclave, going out to where it sits for 45 minutes to dry cycle, and then once it gets put on a storage shelf and stays there. If you can get it from the front line and you can have a system that shows and we can see those defects and everything before the pan even gets wrapped, then you're already 100% ahead of the game, because we already know from the time that we wrapped the pan and to the time that we put it on autoclave and sterilized it, we knew that there was no defects and no holes in that CSR wrap. So then that's when you know, okay, yes, it's more efficient because it's not as expensive as a sterilization container and you only have to wrap it once. And you're able to take that and move it upstairs, know that that pan is sterilized, and you know that there's nothing compromised from the time that it left sterile processing to the time that goes to the shelf. Us having that and us doing all of that together, it will help with, the room efficiency, the cost savings, and making sure that that pan is sterile and that pan is ready to go, and that we know that there has been no cross-contamination, and we know that that pan is ready to go on the back table to give the best outcome for that procedure in the OR. That is what the goal is to make sure that that patient comes out with the best possible procedure with no infections and no chance of infections due to the sterilization of wrapping. to know that we did what we had to do in sterile processing to make sure that wrap did what it was supposed to do and stop cross-contamination.
Creating sterile wrap inspection protocols. As previously mentioned, a critical step in reducing surgical site infections is to develop a protocol for the use and inspection of sterile wrap materials. For sterilization packaging process to be successful and safe, 3 objectives must be achieved as stated by Isham. 1. Allow penetration of the chosen sterilant and be compatible with any other requirements of the sterilization process, such as drying. 2. Maintain the sterility of the package contents until the package is opened. And 3. Create a package that can be opened aseptically without contaminating the contents by the user. Keep in mind that sterilization packaging is an FDA Class II medical device. As such, it presents a potential risk to the patient, and the consequences of using a non-sterile item during a surgical procedure can be life-threatening. This is why choosing sterile packaging materials is critical, as there is no single material that applies to all needs. When choosing packaging materials, Isham guidelines recommend choosing steam sterilization packaging that is capable of withstanding temperatures of 250 degrees Fahrenheit to 275 degrees Fahrenheit. The Association of Surgical Technologists Standards of Practice for Packaging Material and Preparing Items for Sterilization's Standard of Practice recommends requesting samples of sterile packaging materials from manufacturers prior to adoption and purchase of material. By requesting samples, healthcare facilities can test materials to ensure that the wrap meets the needs of the facility and allows the sterilizing agent to penetrate and reach all surface areas of the items to be sterilized. By testing wrap materials, facilities can check to see if the material maintains sterility of the item up until its use, performing as a reliable barrier to microorganisms. According to Isham, ANSI/AAMI ST79, and AST standards, when choosing wrap material, it is critical to make sure that the package is able to be opened in an aseptic manner that allows for the sterile items to be easily removed or transferred to the sterile field without contamination. It conforms to the size and shape of the items. Covers contents in their entirety. Provides for maximum amount of use. Allows air to be completely removed during the sterilization process. The material withstands physical conditions produced by the autoclave, including moisture, pressure, and high temperatures. Materials are permeable to the sterilization agent and moisture. The allowance of escape and removal of the sterilizing agent at the end of the sterilization process. Allows the contents to be dried after sterilization with no presence of moisture. The packaging material must also have the characteristic of being able to be dried to avoid wet packages upon removal from the sterilizer. Allow ethylene oxide gas and moisture to escape during the aeration cycle. Resist tears and punctures during sterilization and normal handling. Does not easily degrade when the sterile packages are stored. Provides a barrier to the penetration of dust and particles and resists moisture penetration. Woven fabric should be free of lint and also free of loose fibers. Must not contain any toxic material or dyes that could produce a chemical reaction during the sterilization process. Reusable packaging should be free of bleaches and detergents that could produce a chemical reaction during the sterilization process. Toxic residues can be harmful to the patient and members of the surgical team who are handling the packaged materials, and the sterile team members who are handling the contents, and it can also cause instrument discoloration. Packaging must promote the integrity of the seal that is used to secure items so that content sterility is maintained. The seal should not spontaneously open when the package is in sterile storage. materials should be incapable of being resealed once the seal is broken or package is opened. And materials should be cost-effective for the facility. Woven packaging materials are available in 140 thread count muslin, which is a cotton, calico, and barrier type cloth. It is typically made of 100% unbleached, loosely woven cotton fibers and made of 2-ply fabric fastened together as one wrap. Other woven fabrics in sterilization are duck cloth, twill, and treated barrier fabrics. Disposable packaging materials are examples of engineered fabrics. There are 3 types of disposable packaging materials: paper, polyolefin-plastic, and disposable non-woven wraps. Kraft-type papers are smooth-surfaced and available in various sizes and are porous or soft good items. Kraft-type paper is also available in medical-grade pouches to hold small parts and instruments. Kraft-type papers are also available as flat wraps. Paper plastic and Spunbound polyolefin plastic combinations are also commonly used and often referred to as peel pouches. Spunbound-meltblown-spunbond flat wraps are widely used. They are constructed by polyolefin layers exposed to high heat and then pressure bonded together to form sheets. These are designed as single-use disposable products and come in a variety of sizes as single or double sheet wraps that are bonded together. When evaluating packaging materials or a packaging system, the healthcare facility should request and review the manufacturer's information to ensure that it is appropriate for the method of sterilization to be used, and to review and maintain a written copy of the sterilization validation studies. When using reusable packaging materials, materials should be laundered, inspected, and properly stored between every use to preserve the packaging properties of the material. Single-use packaging materials should be properly stored to preserve the packaging properties of the material. Additionally, all woven packaging materials should be delinted prior to use. All woven packaging materials should be inspected for holes, tears, and thinning of the material each time after laundering. It is recommended the inspection take place with the use of a lighted table. Defects should be repaired with the use of a vulcanized patch that is heat sealed onto the woven material. A patch should be placed on each side of the defect. Defects should not be sewn. The needle from sewing creates multiple holes in the woven material, producing multiple routes of microbial entry to the sterile field. Multiple laundering and defect repairs eventually cause the woven material product's failure to meet the criteria for the performance and must be retired. The healthcare facility should have a tracking system in place, such as marking grids or barcode systems, to track the number of times a woven product is laundered or sterilized. Check the manufacturer of the woven product's written recommendations for the number of times that the product can be processed and used. AST's standard of practice states all wrapped packages should be prepared to facilitate ease of opening the package and transferring to the sterile field while maintaining the sterility of the contents. To do so, facilities must use the correct size wrapper in order to ensure complete coverage of the contents and sterilization. The wrapper should not be too large in order to prevent air pockets from forming. This can inhibit the penetration and release of the sterilant. It should not be too small as to not allow adequate coverage of the contents and possibly tear at the corners. Wrappers that will be used to establish a sterile field should be large enough to extend a minimum of 6 inches below the 4 sides of the table or basin ring. Wrappers must be large enough to cover the hand of the individual opening it if the package is to be handed to the central sterile technician in the scrub roll using sterile technique or transferred to a sterile field. Before wrapping an instrument tray, an absorbent lint-free linen towel should be placed between the bottom of the tray and wrapper to cushion the corners of the tray and prevent tearing, as well as to serve to absorb the condensation during steam sterilization. Density is a key factor related to the sterilization of items. The more densely items are packed, The greater the percentage that the sterilant will not contact the surface areas of all items, and drying will be inadequate. ANSI Amy recommends that instrument sets should not exceed 25 pounds. Additionally, ANSI Amy ST79 recommends that woven and non-woven wraps should be FDA cleared as medical sterilization packaging systems for use in healthcare facilities. They should be stored and maintained according to the manufacturer's written IFU and selected according to the size, shape, and weight of the medical device to be processed. Items should be wrapped securely to prevent gaps in the wrap material, and items should not be wrapped too tightly because tears and punctures could occur. Once packaging materials have been chosen and implemented within a facility, the preparation of items for sterilization begins after decontamination. When choosing and using non-woven wraps, sterile processing personnel should choose the grade of sterilization wrap according to the size, shape, and weight of the medical devices to be wrapped, the guidelines within the healthcare facility, and the wrap manufacturer's written IFU. Inspect the wrap to ensure that it is free of defects that could have an adverse effect on the performance of the material. Then confirm that the wrap is free of non-fast dyes and is designed to minimize the generation and shedding of fibers or particulates during normal use. Check disposable wraps for manufacturer expiration dates prior to use to avoid reduction in the packaging's ability to perform at optimal standards. When inspecting woven and non-woven wraps, it is recommended by ISHM that inspection is conducted to ensure that there are no tears, punctures, worn spots, or stains from previous use. That inspection is performed using a light table that has a light source built into the tabletop to help spot small holes and punctures. As the wrap is passed over the lighted tabletop, light shines through the small holes and punctures, making them much easier to identify. Additionally, ISHM recommends maintaining proper lighting in the assembly area as the work being performed is very detailed and inadequate lighting can lead to errors and strain. By utilizing a tabletop light, as well as magnifying task lights, ergonomic ease on the central sterile technician is achieved by limiting strain on eyesight, as well as limiting physical strain through the use of a tabletop workspace. By easing strain on the technician, productivity and quality assurance is enhanced. In conclusion, by carefully selecting the proper sterilization packaging materials, patient safety is enhanced, packaging compromise is reduced, and cost savings are implemented. In addition to selecting the correct packaging materials, utilizing tools to inspect materials to ensure the integrity of the material and the instruments being sterilized is paramount to successful sterilization and patient safety. For more information on packaging standards and guidelines, please visit ISHM online at isham.org. ANSI Amy standards can be found at ansi.org. The Association of Surgical Technologists standards and guidelines can be found at ast.org. You can also find more educational content from Pure Processing by visiting pure-processing.com.